I'm purely just winging this. All right, this isn't something I've prepared. This is something I'm basically going to try to live code an observable to you and try to explain what observables are from that angle. A lot of people see observables and they're like, oh, there's some magic to this. It's like, it's not a promise. Promise, there actually is magic to it. There's some scheduling that goes on. There's some state under the hood. It executes things immediately in some cases and later in other cases. Like it's complex. So people assign that same complexity with a familiar type like promises to observables. And I'm here to tell you that that complexity does not exist. There's complexity around how people use observables, but not around the actual type itself. So I'm going to do this on Stackblitz. Some of you may or may not be familiar with Stackblitz. It's a really super cool tool that's basically Visual Studio Code in the browser. If you want to play with ArcGIS, you can actually come in here and start an app right here, and it brings up ArcGIS. I'll show you that really quick. Like some example code, it's already imported the dependency, that sort of thing. This tool, if you ever use it, if you just were to use ArcGIS here and not import the dependency, it gives you a prompt, you click it, and you have the dependency really, really fast. It's pretty cool. But I'm going to do this, and I'm gonna really punish myself, and I'm gonna do it with TypeScript. You're gonna see me casting things as any a lot, just because I don't feel like terribly punishing myself. But so let's go here, and I'll bring up the console. Hopefully everybody can see this okay. I don't need any of this. So what observables really are they're basically functions. They're functions that you call subscribe in order to execute them. You can implement your own observable pattern with nothing more than a function. So I could have this here, and I could call it my observable. And to my observable, I could pass an observer, which is a type that you look at the interface, observer, generic, which means I have to make this generic, and the observer has a next method on it that takes a value, does nothing. It has an error method on it that takes an error of any, could be any type of error, and does nothing, and it has a complete method on it, which returns nothing, right? So this, in a nutshell, is what the observer is shaped like. And then your observable, if you wanted to emit values from it, you're going to say observer next 1, observer next 2, observer next 3, and observer complete. Now, in this case, I'm actually making all of this number, so I can probably just go ahead and say this is an observer of number. Hard code this in here. So this is an observable of the numbers 1, 2, and 3. And if I wanted to subscribe to this thing, I would say my observable, pass in an object with, does something with the value, does something if there's an error, and does something if it completes. Right, logo, not logo. All right. So you can see down here, and I'm going to just put at the top of this console clear. So when this runs, you get 1, 2, 3 done right away. Because I called the function with this POJO object that has the expected interface, and inside of there, I call that interface and I emit values. Pretty cool. This is basically what an observable is. A lot of people don't know that. This is simple. So why would I bother having a whole library around this if I could just build it with functions? Well, there's a few problems with this. For example, I could say observer next 4. And we're going to get 1, 2, 3 done 4. Well, that wasn't really done. That was a dirty lie that it was done. It's not complete at all. So now what do? I could augment my observer here to have something inside of it that says, hey, if something called complete on this, then don't allow next to come through, right? But then I have to do that every single time I subscribe to my observable. That's not great. I could say, well, every time I call this observable, I could say, all right, well, maybe I'll just take this and I'll say observer make safe observer, and I pass it in there. And I have this other method that takes the observer and wraps it in another observer that guarantees that sort of safety, right? But then every time I define an observable, I have to call this make safe function, right? Like that's probably not the most ideal solution. And there's other things to this that you start to see when you start to do things that involve asynchrony or any sort of like wanting to tear things down. So if I wanted to make this a little bit more complex than just 1, 2, 3 complete, let me get back to that really quick. Maybe I want to do like an interval. That's a pretty basic idea. So if I wanted to have an interval, and I believe that this is going to server settings. I might have to refresh this repeatedly if it does not. I want to clear the console. I think I could just hard reload here, but we'll see. I'm concerned that if I start an interval, it's gonna go forever and be a problem, but we'll see. So let's just say that if I wanted to make this like observe something asynchronous like an interval, I would say, okay, well, let I equals 1, so we have some values we can pump out, and then I'm going to say const id equals set interval, and every time that gets hit, and I'm not going to finish it so it doesn't start spamming the console right away. I'm going to do once every second. And then I could return some sort of teardown, because we want to be able to tear this down when we no longer care about it, right? And this is just going to increment I and then call observer next on it. And here, we're just going to call clear interval with the ID. So saying 1, 2, 3, and so on. Now my observable actually returns something I can use for teardown, which I could call it like a subscription, or even just, I don't know, we'll call it teardown. And we can say later on, after a timeout, give it 3 seconds or so. Close enough. There. Typo. I'm gonna call teardown. So we're going to say wait for 3.2 seconds, call teardown. So this ticks along, and then it's about there, and then no more. Teardown was called. And you can see in here, if I console log this, it should be apparent. Space there. And tearing down. So I can even have like a cancellation mechanism like this. But you get into even more problems where, let's just say that I wanted this to go for so long and then complete. Like if I get in here and I say, well, this is a little different. I want to say if I is greater than 3, and observer.complete. When it's complete, I don't want this interval to keep going. Now I'm responsible. I'm on the hook for not only do I have to make sure that my observer is safe and doesn't allow you to call next after you've already called complete or error, but I also have to like make sure that this, whatever happens in here, is called whenever you complete or error also, right? Like you have to make sure that the guarantee that these resources are torn down. So this is why it's not a function, but this is literally the only reason it's not a function. Everything else about observable it's just this sort of shape of function. You have a function that you pass an observer into, and then you return some sort of function that has like a teardown to it. So if I'm going to re-implement this from scratch to make it better, what I want to do is I'm going to have to create a new class called Observable, obviously. And the constructor is literally going to take, I'm going to say this is a init. And it's going to take that same shape function that has an observer, which is an observer t, and returns, we'll call it teardown. And teardown is just a type that just void, right? So this is our constructor for it. And then inside of this subscribe, what we're really doing is we're taking an observer, T, and we're literally just going to say, return this init observer, just to start with, just to make this do exactly the same thing that it's already currently doing. And then now I can take the entire body of this and change this into const my observable equals new observable. This is now an arrow function. I'm going to close that up. And this I have to subscribe to now. That's it. So now we have an observable class that we've started with, but it hasn't added the safety guarantees to it, right? I can still go in here and call next after complete, and we're still going to have that problem. So we need to do something to make this safer. Or maybe I even want to have an API, which ArcsJS does, of where you don't have to have all of these implemented on the observer. You can just provide next or just provide complete or something like that. So what we do is we take that observer and we can have a class, and I'm going to make this class above here. Class, we'll call it safe subscriber, or I'll just call it subscriber. Subscriber. It has a generic type, and subscriber is going to implement observer T. So that means we need to have a next on it. Value of T. We need to have an error on it. Error of any. And we need to have a complete on it, which takes nothing. And what we're going to do is in the constructor, we're going to say that it has I'll call it a destination. You give it an observer. And then inside of here, we're just going to add little bits of state. There's going to be this state that says, let's see, call it closed. And here we're going to say if this dot closed, or if it's not closed rather, then this dot destination next value. And then inside of here, where there's an error complete, we're going to say if it's not closed, typos closed equals true. So now it's immediately closed synchronously right there. And then we're going to forward that along. Oh, not next. And then the same basic idea here is going to happen in complete. Only we're going to call complete. We don't have an error anymore. There. So now I've at least added the guarantee to where I can't go in here and I'm going to make this tick a little bit faster so I don't have to wait so long. Where I can't go in here and say observer. Well, I haven't done it yet. Right now I can say observer next right afterwards, and right, and it's going to keep going. Why do I have so many? Because it's what? Oh yeah. Right. So be it. All right. So let's go here and say. Got haha. So it made it past there. It's still going. It's not tearing down, right, when I call complete. That's still a problem I have to solve. And it's also nexting after completion. So let me make this a little bit bigger again. Oh boy. Let's say, or actually I'll just make the other one smaller. Makes more sense. Oh, I've locked up the browser. Only I worked at a company that could make a really fast browser. Please hold. This is not good. I'm going to end up having to recode all this stuff. Yeah, that's great. We'll see if that comes back, and we'll also see if we have all the code in here. Do we? No, we do not. That is not good. Maybe close this. Why? Right? If I could, I can't even right click this. That's how bad this is. Oh wait. It came back. Yeah, okay, there we go. Doink. That's all I wanted. All right, so back to what I was saying. So this is bad. It doesn't like that. It didn't actually build that. I have to put a number out of here, like something that absurdly I wouldn't get to. But we've defended against this successfully now. Wait, we didn't defend against this. Why is it doing that? So observer next, it's calling complete. Oh, because it tears down before it gets to call complete. Ha ha. So funny. So yeah. So it gets to done, and then it's still allowing this to continue on through here. So that's a problem. We don't want that. And so it should never ever say 99. We should definitely stop it from doing that. And we've got that now with our subscriber. So we're going to use our subscriber to wrap our observer, which is obviously not safe. Our observer is just a plain dumb object with 3 functions on it that you can call in any order you like, anytime you like. So subscriber is going to add some sanity to that. And what we're going to do is we're just going to take our observer inside of our subscribe, which is up on our observable here. And I'm going to say subscriber equals new subscriber observer. And then I'm going to pass subscriber to it. So now I've solved that problem at the very least. It no longer allows you to next or complete afterwards. However, if I was to make this teardown last a little longer, it'll be more obvious that there's a problem there, where basically it should have torn down right synchronously as soon as it was done, but that interval keeps going, right? So it keeps going basically until I call teardown. If I remove this here, that interval is going to eat memory and last forever. I want that teardown to happen at exactly the same time as I call complete. So I need to tie this in some way to my subscriber, to the subscribers, particularly the error in the complete method. Furthermore, if I call teardown on this, I want to make sure that if I've implemented some sort of observable here that has some additional code that's running, like you can't still next into that observer if someone like subscribes and then synchronously unsubscribes like right afterwards. You don't want to allow next to still be called inside of the body of that thing. And it's technically possible. So what we need to do is we need to tie it kind of both directions. So first I'm going to deal with the making sure complete calls some sort of teardown. And what we're going to do is I'm going to create a class called subscription. And it just has this unsubscribe method on it. And in this case, I could either add an add method as ArcGIS does, or I could even have it passed via the constructor. In this case, I'm just going to have an add method. And you're going to add teardown to it, which is teardown. And internally, it's going to have what's called teardowns, push teardown. And I need to add a private property, private teardowns equals array. And what's going to happen is inside of here, it's just going to say, all right, for tear down, this tear downs, tear down, basically. And then you could also clear it if you want. So when you call and subscribe on this subscription, it's going to go through every teardown you've added to the subscription and call it, executing the teardown. And what we'll do is we'll say, that, okay, well, this is now going to return a subscription. I'm going to break up a whole bunch of stuff because I'm returning the wrong thing there. And I'm going to create a subscription right at the start. Subscription equals new subscription. Subscription. I'm tired. And then here, I'm going to return the subscription. And before that, do subscription, add whatever comes out of that. So now I've got that. It's going to complain after it hits this because this is now a subscription. So we have an unsubscribe method. We've implemented basically the same thing, only with a subscription. But now I've got this type I can pass to subscriber. I'm going to complain about because it doesn't take that yet. And screen's going dim on me. Up here on subscriber, I need to change this to accept a private subscription. And then closed can be derived from a number of things. But I could just cheat inside of here and say, oh, well, whenever you create the subscription, I want you to add something that says this.closed. True. Right, just to kind of guard against if this is unsubscribed, don't allow anything to next or error. And then down here, right after I send the error, I'm going to synchronously say this.subscription subscribe in both of these spots. So this is effectively observable in a nutshell. This is what RxJS is doing for you. Is it's taking a function that you passed as the body to your observable constructor, and it's adding some safety guarantees. That's all the type is doing. It's not magic. It doesn't have scheduling. It doesn't have any state like a promise. It's not immediately executing anything. It's wrapping a function in something of a particular shape. And from that, what we have is now we have this thing that I talked about before, where we've got a set of values. What did I do with my water? I set it somewhere weird. Anyway, we have a set of values over time. And then we get into what is really exciting about RxJS, which is operators. And so what operators are is they're simply these things that transform one observable, which is this simple thing, into a new observable, which is a different simple thing, which is they're just functions. You're transforming functions into functions. So you're taking a function, you're applying operators to it, and building a new function is what you're really doing. So when you subscribe to it, it executes whatever function you've built, which is composition of a whole bunch of functions under the hood. Now, the way that we do this in Rx is a little bit different than in the past where you had dot-chained operators. So a dot-chained operator would look something like, oh, in my observable, I'm going to have map. And I'm going to say map, you give this function. I'm lazy, I'm going to put any there. And then what I'm going to do is I'm going to return a new observable. And that new observable gives me a subscriber. Here, actually, I'll make this a little better. Takes a value of t. Thank you very much. Which goes to R. So this is my member map.chain version of this. And this is going to be an observable of R. Expects me to return some sort of teardown. And oops. inside of here, what I'm going to do is I'm going to subscribe to the source, which is this. And I subscribe with a brand new observer. And that observer's whole job is going to say, hey, pass this on to the subscriber, but only after I apply this function to the value. And then the rest of it is going to be error. It's going to be passed through. So error, any subscriber. And the next one is the same thing, only with complete. It doesn't care about that or this. So this is what a map function looks like. And so now I could go down here and be like, oh, I've got my observable, I'm subscribing to it. And I want to transform it in some way. So like right here, I'm going to say map, let's add 100 to it, right? So I've added 100 to every one of these. But this is all an operator is this function that takes an observable and returns a new observable that subscribes to that source observable with some custom subscriber that this observer here is forwarding on to this observer here. So when you subscribe, you're kind of chaining observers together, right? And so the more maps I put in there, the bigger this chain of next becomes. But that's what it looks like when it's dot chain. So this is where we came from before. And the problem with this is, as I stated, there's so many things you can do with a set of values over time, so many different operations you can perform, that now, if I were to provide all of them to you, you have this exhaustive list of like 60 plus things, which, by the way, I inherited, came from a compiled language like C#, where the size and the number of these things doesn't matter, because it gets compiled away at build time. And I've got all these things in a prototype. Then I have to ship it to the browser, and you've got 200K of stuff that you didn't really want shipping with your code. So the first pass was, and you saw this in RxJS5, was like, oh, well, we can do this thing where when you import a particular file, it automatically augments the prototype. There's problems with that. If I have a library that uses map, now everybody's observable has map on it, and they start depending on that, and then I decide I don't need map, I remove it, and I break everybody downstream. There's no way for me to know how I did that, because I was mutating global scope in that prototype, in observable.prototype. So that's one problem. There's other various problems around dot chaining. It's not as easy to break apart into various sections of things. So the solution to this, and the other thing is you can't tree shake away something that's been added to a prototype. At least to my knowledge, unless bundlers have improved that since then, I don't think you can. So thanks. So that's another problem. So if you have 60 plus operators and you're only using 2 of them, too bad. Or you've added one with the other mechanism and you stopped using it, you're still adding it to your bundle. So a better way to do this was like, well, what if I implement this as its own standalone function, which involves me just taking this entire thing here and removing it, and then saying, okay, well, const map, this is going to have, blocking my face. So this is going to be the same sort of thing, but now I'm going to have this higher order function that takes a source observable, right? And so instead of this being a source, or the source is actually coming from this higher order thing. And you can implement every single operator in terms of, hey, I'm a function that returns a function of this exact shape, which is takes an observable and returns a new observable. And now I need a way to kind of apply this. And so the rudimentary way was, there used to be an operator called let, which is a horrible name, as you can see from the color coding right here. So we'll call it something else like let, right? And you could provide to this basically any function that had a source observable, source of observable t. So it had to match the same type, and returned some return some observable of R. Provide R. TypeScript was a good choice for this. And I do love TypeScript, actually. But so then inside of here, what this has got to do is it's got to say, OK, well, whenever you subscribe to the result of this, which is a new observable of R, return new observable R. Get a subscriber. I'm just going to call it S because I'm super lazy. And then this returns, oh, you know what? I biffed my mapping function down here. I just remembered. So I subscribed and I never unsubscribed. Who writes this library? This is not a return. I'm supposed to capture that up here. All right. Sorry, my bad. Don't use this library that I'm writing right now. So this requires that I return a teardown because that's the contract of this particular implementation. And inside of here, I'm going to basically just say function, I'm going to pass this to it, and then I'm going to subscribe with the subscriber, which has the same shape as an observer. And then inside of here, I need to capture the subscription again. So this is what let looks like. And that enables me to say, or let looks like that, anyways. And that enables me to try to use map in a different way, where I can say let map, and we get the same exact result. But it sucks to have to do .let map, .let map, .let map, right? Like, why would you want to do that? So there's another way to go about this, and it's a bit of functional programming. And there's a thing, and it exists in like Ramda and some other things called pipe. And I'm going to make pipe right up here. It's very, very small. It's a pipe, and pipe takes a rest of arguments of functions. And these functions, in this particular case, are always going to be of this shape, where it's a source of observable. In this case, any. Typing this is actually hard. To observable of any, I need to define this below because that doesn't exist yet. Where are we? Oh my God. Scrolling. I messed something up. Yeah. What's it complaining about? Oh, it's not an array type. Oops. Really? Array of those. All right. And what we're going to do with this is I'm just going to return something that takes the source observable of any, and then takes that entire array of functions and reduces it such that we take the previous and whatever this function is, and we call that function on the previous value, and we start with the source. Missing that there. So this is all pipe is it's just like, hey, give me an array of functions, and then I want you to apply the result of this one to like pass it to the next one, and take the result of that one and pass it to the next one, and so on. And it's a bit of functional programming magic. You never really have to implement this. It exists in Ramda. It exists in RxJS as a utility helper. But we're going to take this, and instead of implementing this horrifying let method, I'm going to call this pipe. And this is going to take the same basic argument here, which I'm going to turn these to any because otherwise we get into type hell in this particular example. You can go look at the source code for RxJS to see how that has to get typed, but rest arguments are hard. That's the best way to put it. And then here, I've got this, I'm going to return this new observable, yada, yada. We don't even need to do that anymore. We can just take this and say return pipe, pass all the functions to it, and then pass this to that. And it's exactly the same thing as I was doing with let. Believe it or not, only we're allowing more arguments. So In fact, I had an extra step in let I probably did not need, now that I think about it. But now I can say, all right, here's pipe, and I can do map, and then I can map it again. Make it more exciting, right? This is the entirety of RxJS as written up here, really in a hacky way, in what, 20 minutes or something like that. Everything you really need to know about what's going on with Rx is this. The thing that blows people mind, that people can't wrap their heads around sometimes, is the fact that since observables are just functions, you can do anything with an observable that a function can do, right? And so people do anything with an observable that a function can do. For example, sometimes you have an observable that when you subscribe to it, it creates a new WebSocket, and then which creates a WebSocket connection and then next out values. Sometimes you have an observable that, much like a function, the body of it literally closes over an existing WebSocket. Now you're sharing it, right? So and that's the difference between a cold observable and a hot observable. Don't use that terminology; it doesn't make any sense. What happens if you create a WebSocket in your observable, but you also close over one? Now is it a lukewarm observable? I don't know. Sounds great, but that's the general. This is the general basis upon which Rx is built, and it's true in pretty much every language that Rx or some version of Rx exists in. Which it's true for Swift. I think there's an Objective-C version. There's Go exists somewhere. It's not. There's one in the official ReactiveX, but I don't know. RxPHP exists. RxC++ for masochists. CPP. There's you name it. It exists in most languages, and it all carries the same sort of vernacular. So I welcome you. I'll save this and I'll send the link out. You can play around with it. Don't use this. I can tell you firsthand that there are bugs here, and there's a lot of testing to be done around building your own operators. But if you wanted to build your own operators and have them work in Rx, like this here would literally work in Rx. It would be just fine. This observable would work in Rx. This map method, all of this stuff would work in Rx. It's all the same thing. So with that, I'll open it up to questions. So there's two ways to, as you see here, what teardown occurs in 3 different ways. And teardown is what you're really after when you unsubscribe, for the most part. And it's just to free up resources. So teardown occurs when the consumer unsubscribes, or it can occur when the producer of data says, I'm complete, or when the producer of data says, I've got an error. And you can force completion with take operators. So if you say take 3, the implementation of that operator has a counter inside of there and says, hey, I've gotten to 3, I'm calling complete, and then teardown occurs. Now, take until is more useful for the situations you're talking about. So take until, you can say, take until destroy happens. And you can do this, sprinkle it out throughout all of your Rx that you're doing. And what you can do is have like a subject that you next into. You don't have to complete it, you just have the next on it in your onDestroy, and that can like reactively kill all of the other observables that you've got going. So the advantages to this are now you've got this composable thing that you can build from any other observable that you want to. The disadvantage is now you have to make sure that somewhere you've got that take until, like you've kind of moved the problem a little bit. Another thing you can do is you can create one subscription that's like the parent subscription for your classes, which is what I actually most commonly do. And then you take all of your other subscriptions and add it to that. So in Rx, you've got the subscription.add takes subscriptions or teardowns. And you can add a whole bunch of subscriptions to a parent. And then when you call unsubscribe on that, it unsubscribes everything below it. So there's different choices. None of them are right or wrong. I tend to go for the add everything to some parent subscription, unless I have some sort of special need, like, well, now I'm in a situation where not only do I want to kill this observable if the component unmounts, but I want to have a button that can kill it also. Now I've got 2 ways to kill this. I should probably use take until. Sure. So the question for people streaming is, now that I'm on the Angular team, do I have any ideas about how basically RxJS could be better integrated, or the user experience could be better for people when it comes to Rx and Angular. I do think, so we have this really nice user experience around subscribing, which is good. We don't have the best user experience around getting observables out of your template. And I think it's a sore point in particular when it comes to certain things that can happen around server-side rendering or other things like that. So the idea is, and there's actually some design docs around this, is to add some syntax to the templates that allows you to say, this property on this component is an observable, and like this button or whatever in the template is nexting into this observable, and you get a cold observable instead of having like a subject of that when you subscribe to it does the work of binding to the events or whatever for the actual element on the page. So that's one side of it. So like making it easier to create observables from user events is one. Another one that I'd really like to dig into is trying to provide some kind of blessed ergonomics around the HTTP client, as far as, because I think it's a really common use case. People want to multicast their HTTP results, but not always. And you don't want to force the always on them, and you don't want to remove cancellation on them, but you want to make sure that you can cover the 80% use case for people in such a way that maybe they don't always have to use share, or maybe they don't always have to use concat-map or whatever, like just to try to make their lives a little easier. But that's still something that needs a lot of exploration. But those are areas that I would keenly look at. So that way, if someone wants to use Angular, like I would like it if the RxJS stuff didn't get in their way. I think a lot of people really like it and really enjoy it, but there's some people that don't. So that's kind of where I would personally look. I think there's some architectural gotchas there a little bit, because for a while, to repeat the question, are there any gotchas around Angular change detection and like emissions from observables, presumably subscribed to a pipe async, right? So obviously, if you subscribe to an observable and you're just setting state on your component, then that's going to go through regular change detection, just like any other code you might write does. In the case of pipe async, for a while, and I don't know if this has changed, I sincerely hope it does, but in the case of pipe async, there's this interesting thing that Angular does where it's like, oh, well, I see you've subscribed to this observable. When it emits, I'm going to run change detection. And in reality, if with that pipe async you know what you're binding to, and you have an event, you probably could just set that directly and not have to go through the rigmarole of change detection. So I think some people that know Rx well, that are new to Angular, assume that what I just said is probably what's happening, and I don't really think that's the case right now. I know it wasn't in the past. It may have changed out from under me. There's a lot of people working on the code base, and I haven't looked at that in a while. But so don't take it as gospel, people online. But there's some weird hoops that get jumped through, I think, in pipe async that probably don't need to be jumped through, at least from my understanding of it. But that'll be cleaned up fairly shortly, if that is.